So yeah, we are the St. Paul's team, number 1. Just to explain quickly, we didn't get any results from GPS, as far as I understand it, the gamma radiation. But for what we did get, I'm going to leave William to explain the rest. As far as I understand it, the fourth form also want an introduction. So their project did have some difficulties, and I'll let them explain more on that. But thank you for listening to me. Thank you.
Hello. Good morning. It's a pleasure to see you all today. Now, we have been looking at our data this evening, and I must say it was somewhat crushing in parts, because despite hours of painstaking work, toiling away at the great coalface of Arduino code, we have failed successfully to collect GPS, longitude, latitude, time, date, course, speed, satellite count, or any other GPS data. And the reasons for this are, shall we say, still under investigation. If it does turn out to be an issue with the GPS module, that may be having a rapid encounter with a hammer in the near future. However, I am glad to say that we did get humidity and temperature data, and others, but I'll come on to those in a moment. I have only got today a graph of humidity and temperature against pressure. Now, we were using a rather, I think, cobbled together, if you'll excuse the term, a rather last-minute solution for recording pressure, but we have fudged it a little so that it looks about right to us, using a scaling factor which is applied linearly across the whole range. So if you look at this, we have the temperature is given with the blue line. This is only during the flight period. We took, I believe, a total of 11,467 samples, of which about 2,000, 3,000 were during the flight itself. And yes, we're not entirely certain if we got all of it, because at the end of the flight we noticed we had headers rewritten again. In other words, the system had rebooted, so maybe voltage dropped out, maybe loose connection, who knows. But the important thing is we did get some data during flight, and so you can see temperature actually at launch was running as high as 32 degrees. It had earlier got up to 38, according to our temperature sensor, which of course was located at the top of the gondola. That drops fairly rapidly, much as one would expect. We're going down to about 300 hectopascals on the x-axis here. So that's probably obviously the sensor which we were using is not ideal for this sort of thing, and so it stopped reading accurately at about 150, as you can see here. But you can see that drops quite smoothly until it roughly levels off at -2, which is evidently where the equilibrium settled in the end. Humidity begins fairly low because, of course, it was inside a warm capsule, so moisture was being driven out in any case, and that starts about 15, drops very rapidly as the air pressure drops, because, of course, as the air pressure drops, the capability of the air to hold moisture also drops. Then that plateaued for a while before we had a slight spike, and we are open to suggestions as to what may have caused that. And then, of course, we returned to a rather more usual reading of 50 to 60% when the capsule was on the ground. Now, I'm just going to talk briefly about the other data we got. We had on board an MPU 6050 chip, which is from InventSense, and that was intended to measure 3-axis accelerometer and gyroscope. And that worked well, and we've got data from that as well, but because that's a lot more complicated, we're still in the process of looking at it. And for other sensors, we had gamma radiation. I am happy to tell you that the astronauts of tomorrow need have no fear, because we have proved beyond all shadow of a doubt that there is no radiation in the upper atmosphere whatsoever. I'm glad you'll speak about that. And finally, yes, the MPU 6050 rotational and acceleration data, we are still in the process of analysing. What we think is going to be quite an interesting thing to do with that is to attempt to make a primitive sort of inertial navigation system. In other words, we will use the acceleration readings to calculate, according to theory, where the gondola ought to have been after a given number of readings. But this is quite inaccurate because the accelerometer, because it's a very small accelerometer, the chip itself is about that size, and that is taking all of these readings. It's quite a small scale and the accuracy is not perfect. There is drift in the gyroscopes and so on. But through the process of integration we can theoretically work out the position over time. But of course each integration introduces ever more inaccuracy. But what we are considering doing is applying a system called Kalman filtering to it, which essentially takes a weighted average of previous values and then compares the likelihood of the next value being accurate. In other words, it uses a model, I believe the technical term, and I'm sure many of you know a huge amount more about this than I will correct me if I'm wrong, I believe it's called the Markov state model, but that's rather irrelevant because I don't know what that means. Now, the point is that this should allow us to get slightly more accurate data, but at the end of the day we're not certain what we're going to get from that, but we have been able to locate from high accelerometer maximum readings the launch and recovery, we think. We'll also be looking at that to see if we can glean something about the movement in turbulence, but as I say, this is still as yet unanalyzed. Thank you very much for listening. I'm sorry to have droned on so much, and I wish you all a very safe journey.
Like you wanted an explanation for when did it occur?
It was probably on the way down somewhere.
Do you have an idea of how many minutes that would have been?
Well, no, we were relying on the GPS to plan it. And if we didn't have a sample, so I looked, we would take yourself and GPS in seconds.
Because that would all give us the best clue. Because from that time you can drive it up.
I was wondering actually whether it might have been the primary school's notes trickling down.
There was nothing in the question.
I doubt it.
Just in terms of drive, I mean, in any event, the melt is lower than...
Wouldn't have been a Clyde? Wouldn't have been a Clyde?
Maybe that's why I would like to know when it
It
happened.
was certainly on the way down. That we had that.
Yeah, okay.
As I say,
It might have been, as you come from a very cold region and you're going to warm regions,
you do have
it might have been a problem.